How to balance the chemical equations in 3 easy steps. If you follow these steps, I'm sure you'll be able to find it really easy and a lot of fun to balance chemical equations. Let's take step number 1. In this step, you need to list. List all of the elements that appear in the chemical equation for both the reactant and the product side. Let's take a look at this equation that we have here. Looks pretty complicated, but it's really not. The elements that we have on the left-hand side are lead. We have oxygen, we have hydrogen, and we have chlorine. Because of the law of conservation of mass, you can expect to have the same elements on the reactant side. So you see that we have lead, hydrogen, oxygen, hydrogen, and chlorine. You're going to count the number of atoms. In this case, we'll count the number of atoms for each of the elements that appear in both the left and the right-hand side of the equation. So let's take a look at this equation further. On the left-hand side, you can see that we have 1 atom of lead. We have actually 2 atoms of oxygen. Imagine that the subscript here, you're going to be multiplying everything inside that by 2. So therefore, we have 2 atoms of oxygen. Let's look at hydrogen. Hydrogen, we have 2 atoms of hydrogen here, but we also have 1 atom here. So that makes a total of 3 atoms of hydrogen. And we have 1 atom of chlorine. On the reactant side, we have 1 atom of lead, we have 1 atom of oxygen, we have 2 atoms of hydrogen, and we have 2 atoms of chlorine. Obviously, you can see from this that we do not have a balanced equation. So let's move on to step number 3. Step number 3, you're going to be balancing the equation, making sure that you have the same number of atoms for each element on both the left and the right-hand side. You do this by adding a coefficient. Coefficients are used to balance the atoms on each side of the equation. You never add subscripts. That would be changing the compounds entirely. You cannot do that. So let's continue with this equation. It looks that we're fine for the lead when we first look at this because we have 1 atom on each side of the equation. Going down next to oxygen, we see that we have 2 atoms of oxygen here on the left side and only 1 here. So in order to balance that, we're going to be adding a 2 in front of this H2O. When I do that, I now have 2 atoms of oxygen. Again, imagine that there's a parenthesis around this compound and everything inside that is going to be multiplied, in this case, by 2. That being the case, I now have a total of 4 atoms of hydrogen. Moving down next to the next atom for for hydrogen, I have 4 atoms on this side and 3 atoms on this side. Well, that seems to be a little complicated. And maybe what we can do is just go down to the next one and see if it'll all work itself out. I have 2 atoms of chlorine on this side and only 1 here. So by adding a subscript 2 in front of the HCl, I now have 2 atoms of chlorine on this side. I now have 2 atoms of hydrogen and 2 atoms of hydrogen here, so the total amount of hydrogen I have here is 4. So you can see that that kind of worked itself out. Many times you have to go back and forth in order to get the sides balanced. So I seem to be fine for the lead, I'm fine for the oxygen, I'm fine for the hydrogen, I am fine for the chlorine. And here you go, this is your balanced equation for this equation. Let's make it a little bit harder and take this next example. I've already written out the number of atoms that we have, listed the atoms that we have. So step 1, again, is listing the atoms. We've done that. So let's go ahead and do step 2, where you have to count the atoms. We have, in this case, 1 atom of aluminum. We have 3 atoms of bromine, 2 atoms of potassium. We have 1 atom of sulfur and 4 atoms of oxygen. On the right-hand side of the equation, we have 2 atoms of aluminum. We have 1 atom of bromine, 1 atom of potassium. in this case, there is 3 atoms of sulfur. And there is, in this case, 3 times the 4, there is a total of 12 atoms of oxygen. This makes this equation a little bit more complicated. This 3 is multiplying everything inside that parentheses. But note that this subscript here on the oxygen does not affect the sulfur. Okay, so now let's go about balancing this equation. We can see that I have 1 aluminum and 2 aluminums here. So I can fix this left-hand side by adding a 2 in front of that compound. I now have 2 aluminums. I have a total of 6 bromines now. So I'm going to put a 6 right there. Let's move down here. Now that I have 6 bromines here, I have 1 here. So I can fix the right-hand side by adding a 6 in front of this. When I do that, I now have 6 bromines, but I now have increased the number of potassiums to 6. Okay? Moving down to the next element. I have 6 potassium on the left side and 2 here. So I can add a 3 in front of this compound here. And when I do that, I'm now going to have a total of 6 potassium. I'm going to have a total of 3 sulfurs as a result of that. And 3 times 4, I'm going to have a total of 12 oxygens. So let's take a look and see if we have a balanced equation. We have the same number for aluminum, the same number for bromine, the same number for potassium, the same number for sulfur, and the same number for oxygen. So there is your balanced equation for this pretty hard chemical equation. I hope you learned how to do this. Remember to follow the 3 steps: to list, to count, and then to balance.